Let's take a look at an example where we are evaluating functions at given x values. So in this example here, we're given the function 3x minus 1, a linear function, a polynomial linear function. I'm going to pause the video, give you all a chance to complete this one. So you'll see for our first example, we're given that x equals 2. When I substitute 2, I multiply it times 3. I get 6. I subtract 1, applying the appropriate order of operations, and the result is 5. For the second example, now I am substituting 2 over 3 for x. When that happens, conveniently, the 3 that is being multiplied times the 2 over 3 gets canceled out by the denominator, because 3 divided by 3 is 1, times 2 is 2, 2 minus 1 is 1. For the next example, you will note that I have k to substitute for x. When I substitute k for x, the only change is instead of x, I have k, 3k minus 1, and I cannot evaluate that any further. And you see for the last example, I am given the task of substituting k plus 1 for x. Again, paying attention to order of operations, I expand the parentheses, meaning 3 times k, 3k, and 3 times 1, which is 3. Subtract 1, I'm left with 3k plus 2, and I cannot simplify that any further. So let's take a look at another function, this one being a polynomial quadratic function, where we have 3t squared minus t. Be careful when you're given the values that you substitute the value for x, or sorry, in this case for t, you have to substitute it twice. I will pause the video and we will discuss the solutions in a moment. Our first example, we have to substitute -4 for t. When I substitute a negative, I need to be careful when I'm evaluating. When I have -4 and I square it, the result is positive. So -4 squared is 16. When I subtract a negative, it's the same as adding it. So you see that the subtraction symbol has changed to addition. So then it's a matter of, once again, performing our order of operations. 3 times 16 is 48. 3 times 10 is 30. 3 times 16 is 18. Add them together. 48 plus 4 is 52. Looking at our second example, now I'm substituting 1 over 3. When I square 1 over 3, the result is 1 over 9. 1 over 9 times 3 is 3 over 9, which also reduces to 1 over 3. But I also remember I have to subtract 1 over 3. When that occurs, I am left with 1 over 3 minus 1 over 3, which equals 0. For the next example, we are asked to substitute k for t. And once again, all that I could do is substitute k, and I cannot simplify that any further, and I'm left with 3k squared minus k. You will see for our fourth and final example, now we are asked to substitute k plus 1. Again, pay attention to the fact that I am using parentheses because, well, a couple of reasons, one of which because we have subtraction in between. When I substitute k plus 1 and square it, that's the same as saying k plus 1 times k plus 1. So you can't just square k and square 1 and leave it be and call it a day. You also have that middle term, because when you expand it or perform FOIL, you always will end up with a middle term. The quick way to do that is to multiply the two terms, so k and plus 1, which is 1k, and then double it, and that gives you your middle term. So you'll see that k plus 1 squared is k squared plus 2k plus 1. And now look, I substituted k plus 1 for t. When I subtract it, I can now expand that negative, imagining that there's a -1 on the outside of that parentheses. When I do that, that negates or makes the k negative as well as the +1 negative. Then I expand the 3. So the 3 times the k squared, 3 times 2k, and 3 times 1. Once I have all parentheses gone and all exponents gone, now I can simplify it. The 3k squared stands alone. It cannot be eliminated. There's no other k squared. But I have 6k minus k, which leaves me with +5k. And I have 3 minus 1, which leaves me with 2.